For those who don't know me, my name is Tim Schroeder, and I'm the product manager for the process development Opus Pre-packed column portfolio. The name of the product line is Opus PD, and PD is standing for process development, and all columns are lined up in the back of the room, and I would be more than happy to answer any questions during the day. But now let's talk what we are trying to accomplish in the next 15 minutes. So first, we would like to review together with you the deployment of high-throughput screening technologies in bioprocessing over the last 20 years. Second, we would like to present a case study on the successful application of high-throughput screening for a new modality. And last but not least, and third, we would like to introduce you to new digital tools in innovative technologies both Repligen and Tecan are currently working on to future or further simplify the application of high-throughput screening for you as a customer in the future. But let's get started with the history and the evolution of high-throughput screening and ask ourselves, where are we today? So I personally know that some of you guys in the audience today still remember the days when downstream process development was traditionally carried out with self-packed chromatography columns in a sequentially mode on standalone chromatography systems like ACTA. These studies were stretched throughout months and always facing the risk that you are missing the optimum separation conditions due to the lack of time on the one hand side, but also missing screening tools which allow you to screen all parameters on the other hand side. So the good news is that this landscape has completely changed over the last 20 years, and people started to use filter plates pre-filled with loose resin to conduct or to run batch uptake kinetics or absorption isotherms. But in 2005, some smart guys took it a step ahead, and they developed a real pre-packed miniaturized chromatography column which can be arranged on a 96 array format, and they named it RoboColumn. And believe me or not, but the drawings here on the left-hand side are actually showing the first prototypes in 2005. And during this time, RoboColumns enabled the first time to even simulate real chromatographic runs, which allows the evaluation of dynamic chromatographic parameters, including DBC. And I think we all aligned or agree that during these days, high-throughput screening technologies are broadly adapted in global industry and commonly used to screen resins and separation conditions following a DOE approach. Data integrity as well as scalability has been proven and underlined by a lot of presentations and publications some of you guys have been even involved with. And even some customers are starting to apply high-throughput screening technologies for the development of new purification strategies for new modalities. And I think that answers the question where we are today. But I assume that you are more interested in where are we going. And I personally think that we are now at a point where we need to start focusing on improving the user experience for you guys by developing new digital tools which help to facilitate the ordering process of these products on the one hand side to increase accessibility to product for you guys, and on the other hand side, the execution of experiments as well as data analysis. So let's get started with the front end of the process. The ordering and configuration and quoting of Opus PD products. This has been a really time-consuming and manual task in the past, which involved many individuals. And the good news is that's something we are definitely going to change in the next 2 months. With launching the Opus PD Configurator, which is a fully web-based CPQ tool, which allows you as a customer to configure and to create Opus PD quotes online. And the intuitive user interface will allow you to select between 3 different configurations and to create quotes including RoboColumns, Minichrome column, Valichrome columns, all together. Now let's imagine you want to conduct a screening experiment for an AAV capture step using RoboColumns. And by entering the RoboColumn plate configurator, you will immediately notice the common 96 array format. And you can design your plate layout according to your application requirements by selecting the RoboColumn volume, the functional mode, the resin vendor, the resin type, and the resin source. This way, you can either set different settings for each individual row or copy-paste the configuration across the plate. After you have verified your design and completed your plate layout, you can submit for quote, and a PDF will be automatically generated and forwarded to your working email. I hope that I have been able to demonstrate here that the Opus PD configurator will significantly improve the accessibility to product for you as a customer and therefore increase the buying experience. But let's look further down the process and assume that the plate has been configured, the order has been placed by you, the columns successfully arrived in your lab, and now you're of course keen to execute your screening experiments with a Tecan robot. And with having that said, I would like to invite Simon Fogarty from Tecan, who is going to further elaborate how smart commands, a new advanced user interface will change your interactions with robotic systems in the future. Simon?
Thanks very much, Tim. As Tim mentioned, like him and his team, we're focusing on software as opposed to the hardware. I think we're fairly confident there's not much else we can do with the actual T-Chrome machined piece itself. If you do have a brilliant idea, though, come and see me afterwards and we'll implement it. You won't get any commission on that, but we'll take the ideas. We've been focusing on the software. Within our Fluent instrument, we have the capability of developing what we call smart commands. These are a single command that you can call in the script, and from that, open a window that allows you to set any of the parameters you want in the assay in a single step. So those of you familiar with the sort of multiple thousand-line scripts, those will effectively disappear when this launches later in the year with the next release of Fluent Control. So I've just got the smart command open here. You can see that you can call up the workflow tab. I'll just go through some of these tabs to give you an illustration. You've got 3 options here. Discard the fraction, so simply let the liquid go to waste. Collect the batch, which is obvious, or collect it as fractions. You can pick one of those 3. You can then select, we've got 3 sets of lab where you can select from the source, whether that be sample or a buffer from a reservoir, the RoboColumns themselves, where they are in the plate, how many there are, size, etc., and then the collection, what you're going to collect into, whether it's a plate or a deep well. You can then very easily select the volume of liquid you're going to transfer through the RoboColumns, and you can define that as either the volume in microliters or a factor of the resin volume. And again, as you know with the Fluent, you can do individual volumes per channel. You can select, for fraction collection, either a number of microliters to collect or a length of time for the fraction to be collected. And then finally, you can set the resin volume and work in either microliters or multiples of resin volumes. So this just shows the actual main screen you'll get when you start writing a protocol. You're just going to drag these single commands in, called the T-Chrome command, and from that you can fill in all of that detail and build each successive step in your protocol just by dragging that command in repetitively. You can also, as you see then for each of the command lines here, we've just got 3 put together, an equilibration, elution, and then discard a fraction, and it'll define the parameters for each of those steps. So you can very easily see what you've built and edit it. And then finally, we've just got a quick video here that shows the process in place. So you drag the command over, give it a name, specify the whether you're going to discard, collect as batch, or collect as a fraction. In this case, we're going to discard. You can pick here then how much you're going to dispense per column. You can lock those to set it all to be the same value on each. You can then specify the time on the column in microliters per second. I think we're going to be adding in a flow rate in centimeters per hour. In the later release, this is just a beta version. And then you can select the robocolumn, the reservoir that you're going to come from, and then the robocolumns themselves, and specify where they are in the plate. Like Ken mentioned before, we're at the back as well. Dylan Bagshaw locally from Tecan Service, who I think many of you know, is at the back, and we have a software demo if you need to see it. And with that, I will hand back to Tim.
Thank you, Simon,
I think I'm on time.
for demonstrating the power of smart commands. I personally think that this new interface will significantly simplify the execution of robotic experiments for you as a customer in the future. But now let's have a closer look how RoboColumns and smart commands in combination can be applied for advanced high-throughput process development. And I know that most of you are familiar with the application of DOE for the development and optimization of recombinant proteins and MAPs, but with the current change in bioprocessing and the focus on new modalities, in particular viral vectors, the pressure on process development timelines, faster time to market has been significantly increased. Additionally, the costs for raw materials are very high, and increases in yield, even if just 10%, can save millions for you guys. And this was a driver why we have conducted a DOE for an AAV capture step by actually comparing 4 different AAV capture resins and applying 3 different SIP solutions, including caustic and acidic conditions. And we actually measured the yield, the host cell protein, as well as the host cell DNA removal over 4 cycles. In total, 48 chromatographic runs have been executed in less than 5 hours. If we now have a closer look at the individual plottings, we can identify that Repligen's recently launched AVPure AAV8 resin is showing constant yield as well as HCP at HCDNA clearance across all 4 cycles. And as already pointed out by Ken, the previous speaker, these AVPure AAV capture resins are the only caustic stable resins on the market. But we have taken it a step further and conducted a second DOE in order to optimize or develop the separation between empty and full capsids by screening 7 different anion exchange resins by changing the pH of the wash and dilution step with 3 different salt types. In addition, 70 chromatographic runs have been carried out in less than 10 hours. And even if this data set is not complete, we have at least identified 3 candidates which show binding to the capsids. So I personally think, and even if this data is not complete, that these are 2 powerful examples which demonstrate how screening with RoboColumns can help you to further narrow down your process development timelines and therefore help you to be faster time to market. So if we are now doing our final math together in order to calculate the total time savings, we can summarize that both DOEs have been actually executed in less than 15 work hours, which equals to 2 working days. And following a conservative traditional approach, this would have been taken up to 40 days. So the time savings by just running 2 DOEs for 1 new process might be roughly 30 days. So now estimate that you guys have to develop 10 new processes on an annual basis, depending on your molecular pipeline and the company you are working for. The time savings are significant, hundreds of days, right? So I think it's a very powerful example how high-throughput process development can help you to save a lot of time in the future. So finally, I would like to sum up my talk and answer the question, where are we going? What is next? So what is next? Repligen is going to launch the Opus PD configurator, which has been briefly introduced. Tecan is going to launch smart commands. But we are just about getting started, as already pointed out by Ken. Just within a time frame of 12 months, the next year, we are going to launch an additional series of affinity resins, each targeting a specific modality and therefore overcoming purification demands and changing requirements. All these new affinity resins will be added to our extensive resin library and of course become available in our Opus pre-packed columns, including RoboColumns. So finally, I hope that both Repligen and Tecan have been able to demonstrate that we understand that we are living in a digital era and that we are taking significant steps to further harmonize different levels of technology to further improve the end-to-end experience for you as a customer. And with that, I would like to thank you for your kind attention and hand it back to Julie.